Okay, so our last answer was the 0.75 or 3/4. Okay, no matter which one you use, it's fine. I'm going to store that. I'm going to check it by saying 3 divided by 4. Yes, you can make it as 3/4 or 0.75. I'm going to hit my store button, which is right here, and I'm going to hit my X button. Okay, now whenever I type in X, it's going to put in 0.75 or 3/4. Okay, so I want to know if it's right. So I'm going to put in the left side and then I'm going to put in the right side, and those two should equal each other. So 0.6 x minus 1.3. On the left side, we get this negative 0.85. On the right side, 0.2 parentheses 5x minus 8 ending parentheses, and our left equaled the right. Now again, we could check it by hand, but we have these calculators, we might as well use them, okay? So it would be the same thing as saying 0.6 times our answer, then we're going to subtract the 1.3. Then this one here, again, you're going to do parentheses first. You'd say 5 times this minus 8, and then multiply by 0.2. But our calculator makes it so much easier. Just like our decimals, let's let our calculator do the work right here. Okay, so before I start moving things, getting everything to one side, our x's on one side and our constants on the other, I'm going to go ahead and I'm going to combine those two. Don't worry about if you can't do fractions, okay? I think it's going to give, I think I get negative 1/6x when I do this, okay? But it's okay if you can't, because your calculator is going to do the work for you, okay? And I'll show you two different ways. If you have your fraction key, you're going to hit alpha, F1, and it's number 1 for, this is our fraction key, that's our mixed numeral. This goes fraction to decimal, mixed numeral to decimal. I'm sorry, no, let's try this again. This is fraction, improper fraction to mixed numeral, and vice versa, mixed numeral to improper fraction. And this is fraction to decimal, decimal to fraction. You can tell I don't use this all the time. So I'm going to hit 1, because it's just a fraction. I'm going to put in 2/3 minus, again, alpha, F1, 1, and I get 5/6. And that's going to give me negative 1/6. Okay. Negative 1/6 x minus 3 equals 1/2 x minus 5. Okay, again, I'm going to take all my variables to the left. Okay, so I'm going to get this one over here. I'm going to do that by subtracting the negative 1/2 x, because that gives us 0. So it's not there anymore. But what you do one side, you have to do the other. So when I do this, okay, again, you already have negative 1/6 in here. All you have to do is hit minus, and it's going to take this answer and subtract 1/2 from it. And I could put 0.5 if I wanted to, but I'll go ahead and finish it with fractions. 1. And then I'm going to put 1/2. Whoops. That's not going to work. There we go. And we get negative 2/3 because it gives us negative 4/6, which your calculator is going to reduce it. Negative 2/3 x minus 3 equals negative 5. Now, if you don't have the fraction key, it's going to be harder. I mean, it's not really harder. You're just going to say 2 divided by 3 minus 5 divided by 6, and then you're going to hit your math button, and you're going to have a fractional answer, so I want 1. And you get that, then you're going to hit minus 1 divided by 2, again, math, fraction, and it gives us a 2/3. I'm actually faster doing it that way because that's how the TIs have done it for years. So now I need to get my variables are on the left. I need my constants on the right. So I'm going to add 3 to both sides. That goes away. That gives us 0. And so I have negative 2/3 x equals, that gives us negative 2. If you need to do that on your calculator, you can. Just make sure on your calculator this is your negative. This is all your operations: add, subtract, multiply, and divide. That's your negative sign. Okay, so I'm going to plug in. Now, you have to be able to plug this in correctly in order for it to give you the correct answer. Your calculator will give you the answer that however it is that you type in. You will type it in just like you read it. Negative 2 divided by negative 2/3. Now, if you have a fraction key, you're going to do it like this, okay? Whoops. See, I'm so used to not using a fraction key. Let's try this again. Negative 2/3. Okay, is that right? And you should get 3. Yeah, and we do. Okay. Now, if you don't have the fraction key, you have to be real careful. Okay, this is the one time, if you don't have a fraction key, you've got to put that in parentheses. Okay, and I always say, I mean, I didn't do it up here, but you can never go wrong if you put them in parentheses. But in division, you have to. Negative 2 divided by beginning parentheses, negative 2 divided by 3. Okay, and you get 3. Now, let's check our answer. Remember, right now we have this stored in under our x, so let it store x, and then you go up, and I'm going to do it. I'll just use the fraction key. Okay, this will be the last one I check. I say that, and I probably will have to check others. But negative 2/3 x minus, this just takes me forever, 5, 6 x minus 3. Make sure you type it in correctly. It's very easy to type in the wrong thing. Right here for 1/2, I'm just going to put 0.5. 0.5x just because it's faster. Minus 5. Now, the problem is when I do that, it gives me a decimal answer. This is a fraction answer. You can change one of them. I'm just going to go ahead and change that to a fraction, which I know takes my answer, the negative 7/2, so they match. Okay? All right, so we know our answer is right. Oops, that was from homework too. Let's go on to number 4. Now, number 4 is a little bit longer. Again, I'm not going to skip steps. So when you have parentheses and brackets, you're going to work it inside out. It always goes parentheses, brackets, then braces. Braces are those squiggly brackets. So you're going to distribute. This gives us 10 minus 2x. And now what happens is all that disappears. So I'm going to bring down everything else. 4 plus that minus your 2x. Okay, you still have your brackets. And I'm going to go ahead and distribute over here. 4 times 7 is 28. 4 times negative 2 is negative 8x. Okay, now I still got to simplify this left-hand side. Before I do anything, I'm going to combine my like terms inside there. Right here, negative 2x minus 2x gives us negative 4x. And 4 plus 10 gives us 14. Equals 28 minus 8x. Okay, I'm going to distribute my 2. This gives me negative 8x plus 28 equals 28 minus 8x. Now, there's a reason I always will move my variables first. You don't have to, okay? It's fine if you don't. But this is the biggest reason I went to it, is when you have something like this. Okay, I need to get my negative 8x over here. So I'm going to add 8x. That gives me 0. When I do that over here, that gives me 0. So now I end up with 28 is equal to 28. And you're going to go, oh crap, My x has disappeared. That's fine, okay? Not everything has a solution, and there are problems that have many solutions, an infinite number. Now, when your x's disappear, like they did here, when they cancel each other out, your choices are all real. I think they use solutions in this for this. I teach different classes in different books. Whoops. I can find, okay, all real numbers. Sometimes it's all real solution. And who knows when you're using ALEKS, which one but that's what it is. All reals, or you have no solution, okay? So all real numbers, or you have no solution. Those are your two choices, okay? Now, the difference is this a true statement? Yes, it's a true statement. So now that tells me that it's all real solutions. If it wasn't, if you had 28 is equal to 27, that's not a true statement. It would be no solution. So that means any number, any fraction that you pick, it's going to make the left equal the right. Okay, let's just use 0. Okay, I'm going to store it. And the reason I do this store is it's just so easy. I don't have to worry about it. And by the way, your calculator, 0 comes from the factory stored in X. You just don't know about it unless somebody taught you about it. So we can't use brackets or braces in this home screen. Those, you'll see it on your calculator, but those are for programming. So let me just do this one real quick, and I think this may be the last one that I do, at least checking. We'll do more throughout the semester. So if I plug in 0 here, I get 28. If I plug in 0 over here, okay, that gives me 28. Well, what if I picked, like, let's say, -7/9, and I store that under X? Well, you can bring that back up by just going up here. The left side is this. It gives us that decimal. The right side is this, and it gives me the same answer. If I pick 1,000, well, let's try 100. Let's just do that. Let's do 100.1. Okay, store that under X, and you can highlight by bringing it up, or you can hit second. To get this, you can highlight it and then hit enter, but you can hit second enter. It brings up the last one, but if you hit second enter, it brings up the one before. Hit second enter, it brings up that one. So when I plug that in, it gives us that. When I bring up the right hand side, it gives us that. So see how I had multiple solutions? It's any real solution that you can plug in. You can use square roots, the square root of 5. Oops, stored under X, and bring up the right side, left side, and bring up the right side, and it gives us the same thing. Okay, so now we go to the next problem. Okay, I'm not going to do the whole thing over again because the only thing that changes is the exact same problem, except there's a plus sign. So but the left is all the same. So on the left hand side, when I simplify everything in here, it gives us that -4x plus 14. Okay, just for time purposes. But this is the exact same thing as what's up there. Now, when I distribute right here, this gives me 28 minus 8x. I'm sorry, plus 8x. Okay, so when I distribute over here, I get -8x plus 28, and on the right hand side I have 28 minus 8x. God, I keep saying minus, it's plus. Keep going back to the problem up here. Okay, so I'm going to subtract 8x. I get 0 here. I'm going to subtract 8x. This does not give me 0. Okay, this gives me a -16x plus 28 equals 28. So I'm going to subtract 28 because I want that side to give me 0. If I subtract 28 there, I subtract it here. This gives me 0. So on this side, I get negative 16x plus 0, which gives negative 16x. Here, I have to actually write the number 0. 0 is fine. 0 is absence of anything. A lot of you may be sitting here watching it and you have 0 money in your pocket. Okay, so it's fine. 0 is an answer that we get in math. In fact, it's one of my favorite things to check things with. So, all right, we're going to divide by negative 16 because this side is going to give us 1x or just x, and 0 divided by negative 16 is 0. Okay, so now when you plug this in, 0 divided by negative 16, that gives us 0. Because if it's the other way around, it's called undefined. Okay? You can't take something and divide it by nothing. It's already one thing. So that gives me it's called undefined because we divided by 0. And that's one rule. Well, there's several rules, but that's an important rule in math. Okay, this one right here. This gives us negative 3x. Negative 3 times a negative 2 is a positive 6. We're going to distribute here. 4 times 2x is 8x. 4 times 5 is 20. Equals 10x. Now, be careful. We have a negative outside of the parentheses. The shortcut to this is when you have a negative outside of the parentheses, everything changes. So this is positive, it becomes negative. This is negative, it becomes positive. That's how I do it, just changes it. But why does it change it? Well, because really there is a number here, it's negative 1. Negative times a positive gives us a negative. Negative times a negative is a positive. Okay? Or you don't even have to put the 1 there. You can just distribute the negative sign. Negative times a positive is a negative. Negative times a negative is a positive. Okay, so now I'm going to combine my like terms. I'm going to simplify the left. That gives me 5x. 6 and 20 is 26. Over here, that gives me 5x plus 23. I'm going to move my letters, my variables. So I'm going to subtract 5x because I want to get it over here. Okay, that gives me 0. If I subtract 5x there, I got to subtract it here. This gives me 0 as well. But 0 plus 26 gives me 26. 0 plus 23 is 23. So I'm going to ask you, is this a true statement? And you're going to say no. So your answer then is no solution. And I'm really lazy. I don't write out the whole word solution. So these are not equal, so it's no solution. Up here, they were equal as a true statement, so it's all reals. Okay, now, solving rational equations. I'm just looking to see how many more. Okay. Okay, I teach it to get rid of our denominators. Okay, so in order to do that, there's two ways of teaching it, and I go back and forth. But we find our least common denominator. So in this particular problem, I look at my numbers and go, okay, 4 and 2. What's the smallest number that both of them will divide into? So it's going to be 4 because 2 goes into 4. A lot of people, careless mistakes, they'll say 2. No, that's a factor. This is a multiple, meaning 4 won't go into 2 even. I mean, it does as a decimal, but 2 times 2 gives us 4. So you always want to pick the larger number. And then we also have to worry about the x. So our LCD is 4x. Now, some of you are going to go, well, how did she come up with that? Okay, well, here's another way. If I did my factors of 4, it's 2 times 2. That gives me 4. My factors of 2 are 1 and 2. I never use factors of 1 because 1 doesn't do anything, okay? All right, so it's 2. I'm sorry. Oops, you know what? that is it, but our next one is 2x, right? So the way we get that is 2 times x. And then our last term was x, so the only way is 1 times x or x. Okay, to find your least common denominator or multiple, whichever way you want to talk about it, okay, is look at what they have in common, okay? They both have a 2 in common. Oops, that's a bad oval there, okay? So I am going to write one of them down. They also both have an x in common. So I write one of them down. Now you ask yourself, what do they have left over? Well, there's a 2 left over. So you have to tack that on as well. So 2 times 2 is 4x. Now, there's something that I didn't do before I started getting into that, is you need to find excluded values, okay? These are values that make the expression undefined. Basically, if it has an x in the denominator, there are certain numbers that x is not allowed to be. To find those values, even though we know the denominator makes it undefined when our denominator is 0. So go ahead and make your denominator 0 and solve. Okay? So divide by 2. So x is not allowed to be 0. Same thing here. If you set that equal to 0, because sometimes you can have more than one value. So in these problems, x is not allowed to be 0. So if our solution comes out to be 0, we've got to kick it out. Okay, that is called an extraneous solution. You know, you did all the math right, but it's not allowed to be. So, all right, what I'm going to do with this LCD is I'm going to multiply the left side by that and the right side. That means I am going to multiply each one of these by that LCD. I do it like this: times 4x times 4x times 4x. Because I multiply fractions differently than probably the way that you learned them. All right. When I do this problem right here, this 9/4 times this 4x. 4 divided by 4 gives us 1. So those cancel out. And then I have 9 times x, which is 9x. Now, then I'm going to go to the next one. And I say, okay, my x's cancel to give me 1s. 2 goes into 4 2 times. So 1 times 2 is 2, so I have minus 2. And then this last one, my x's cancel, and 4 times 4 is 16. Okay, that's how I do it. If this is too hard for you, what you can do is go over here and go, okay, 9/4, 1 over 2x, and 4 over x. Now, what you do with your LCD, once you find it, is you multiply everything by that least common denominator over 1. Now, you probably were taught, where I was taught to cancel the 4's like I did up here and get 9x. You were probably taught to multiply straight across and get 36x over 4, which gives us 9x, because 36 divided by 4 gives us 9. Okay? Right here, I cancel my x's and I say 2 goes into 4 2 times. Okay, but you were probably taught to multiply straight across. 1 times 4x is 4x. 2x times 1 is 2x. And now reduce. 4 divided by 2 is 2. And x divided by x gives us 1. So 2 times 1 is 2. So I have 9x minus 2. And then here you probably were taught 4 times 4x is 16x over x, and then your x's cancel to give you 16. All right, so now what was a hard problem now becomes an easy one. Our letters are on the left, so I'm just going to take my 2 over to this side by adding it. That gives us 0. I'm going to add 2 there, so I get 9x is equal to 18 divided by 9, and x is equal to 2. Okay, so now you can take this, store it, plug it in. Okay, I'm assuming it's right. I'm not going to check my answers, but you should if it was a test. Okay, or if you have to get the problem right for whatever reason. But you always want to check your answers. Now, make sure, as long as it's not 0, okay, it's a possibility that it's correct. It's only right if you did all the math right. Okay, here, let's find our restrictions first. Our excluded values. I call them restrictions. Sometimes they're excluded values. So what you're going to do is you're going to take any denominator that you see and set it equal to 0 and solve. So you would subtract 3, and you get x is equal to -3. So it can be any value but -3. If we come up with that, we got to kick it out. Okay, so we're going to find our LCD. Now, this one's a little bit harder than what was up here. So here's how I teach this. Now this has a denominator of 1, right? So we don't really have to worry about that. I go ahead and I write down my first denominator of x plus 3. Then you go to your next one. Okay, it's a 1. If I multiply this times 1, I'm just going to get that. So then you go to your third one, your next one, and you ask yourself, do I already have it in the list? If I do, then we don't need another one. We don't need another one. So we found our LCD. So again, what I'm going to do is I'm going to multiply everything I see by this LCD. Okay, now I do my work over here because this is how I do it. That cancels, so I'm left with x plus 6. Then I have minus 2 times that x plus 3 equals, this cancels with that, so I get 1, and 3 times 1 is 3. Now again, that's how I do it. You're going to have to do it the same way even if you go over here and rewrite it. Because again, you're going to take your least common denominator and multiply it by that over 1. Okay, so this over that gives us 1. You can cancel as long as one's in the bottom, one's in the top. It doesn't matter. They don't have to cancel this direction. It can be diagonal, okay? So, because x, whenever you take something and divide it by itself, it gives us 1. So x plus 6 times 1 is x plus 6. Right here, it's the same thing I'm going to do over here, but I'm just going to say 2 over x plus 3. Yes, we could. I count this as a -2, so if I was going to do it like this, I would be putting -2 here. So I'm going to do that. And then when I distribute that -2, I get -2x minus 6. And then here, these cancel to give us 3. So then I have x plus 6. I have this -2 times x plus 3, and then I have 3. So I'm going to go ahead and finish this part out. This gives us -2x. -2 times 3 is -6 equals 3. So that's the same thing I got there. All right, going to combine. That gives us -x. Positive 6 and -6 give us 0 equals 3. Now, we don't want to know what a -x is. We want to know what a positive x is. Well, there's really a -1 there. So we're going to divide both sides by -1. So we get a positive x equals a -3. So if I go to check this, if I go ahead and see, that's a restriction. So I can't have that answer. So I got to kick it out. But if you were to check it, oops, got to go back to my fraction. and put, oh, you know what I need to do? -3, store x, okay? And then I'm going to hit my fraction key and put in x plus 6 over x plus 3. Then -2 on the left-hand side is going to give me an error message. And it says divide by 0. That's because when you plug that in, my denominator gives us 0, and that's undefined. So in this particular case, you got to kick that out, and there are no solutions. And in your online component, in ALEKS, it might say no real solutions. So, okay. Number 9. Okay, so first thing I'm going to do is I'm going to factor this. So I'm going to factor out a 3 right here. Okay. So my restriction, if I factored it wrong, at least I caught it early on. When I factor out a 3, I get x plus 5. All right, so what I'm going to do is I'm going to find my restrictions. So if I took my x plus 5, I'm going to set it equal to 0. I'm going to subtract 5 from both sides. So x is not allowed to be -5. That's my restriction. Okay. Or they call it, what do they call it? Oh, excluded value. Okay, same thing. And in your online component, it might even say what will make this undefined. This problem undefined. Now, I would do the same thing with this, but if I do that, it's still going to give me that -5. Okay. Subtract 15. And you get 3x is equal to -15. Divide by 3. Getting messy because I'm trying to do it in a hurry. And x is not allowed to be -5. Okay. And this one doesn't have a denominator. It's 1, so it doesn't matter. All right. So let's find our least common denominator. Now this one's going to be a little bit different. Okay. Okay. So how do we find our least common denominator? Every single time, take your first denominator and write it down. X plus 5. Now, go to your next one. Do we have a 3 already listed? We do not, so we need to list it as part of our factors, part of our LCD. Now, I know I put the 3 at the back side. I really like it on the front side, but that's okay. Then I go here. Do I already have an x plus 5 listed? And I do, so I don't need another one. So I have found it, and then this, of course, this has a denominator of 1. We don't need it. So this is our least common denominator. So again, I do it like this. 3 times x plus 5. I multiply everything by that 3 times x plus 5. And I just do it here. But again, you can list it. It's going to give you the same thing. So I do it like that. That cancels. So I get -7 times 3 is -21. Right here, my 3's cancel, my x plus 5's cancel, so I have just plain x -4. And here I get 3 times 3, which is 9. 9 times x is 9x. And 9 times 5 is 45. Now, again, that's how I do it. If you have to go over here and do this, list them this direction, that is fine. Oops, I'm going to put this in factored form. Okay, I list my whatever I'm doing up here, and then over here I do my multiplication. It's perfectly fine. I'm just kind of lazy. And I know things are going to cancel, so I don't really do it. I just do it like this. Okay. Let's say we did it this way. These cancel. -7 times 3 is -21. Right here, these cancel. These cancel to give us 1s. Negative 4 times 1 is negative 4. And then over here I get 9. Okay, 3 times 3 is 9. 9 times x is 9x. And 9 times 5 is 45. So I put negative 21 equals negative 4 plus 9x plus 45. All right, combine my like terms before I start moving things. I'm going to put 9x first. Then I have this, negative 4 plus 45, which gives us 41. Now I'm going to subtract 41. Now here, my variables are only on the right-hand side. So I'm just going to leave it. I could take it to the other side, but it's another step. So if my variables are on my right, I'm going to take my numbers to the left. That way it just shortens it. Over here I get negative 62 equals 9x. So now when I do negative 62 divided by 9, oops, hold on just, right here, divide both sides by 9. And I'm just going to bring that down, okay? But if I did not, let me just make sure. I don't think it reduces. No, it does not reduce, okay? So I would just bring it down, and I just checked it on my calculator. I did an error up here, but see, it just gives me that. So just bring negative 62 over 9 down. Is it a restriction? No. Okay. So now you can take that, store it, plug it in. The left side should equal the right, assuming I did everything correctly. It's hard when you're doing these at home because sometimes you might make a mistake and nobody's here to watch you. So I apologize. Just if you find a mistake in the videos, just let me know. Okay. Before I get started, I'm going to factor this here. Now this is going to factor as y plus 3, y minus 1. Okay, so I'm not teaching factoring. We already did that in Unit 1, Homework 1. Now you just have to know how to factor. Okay, so first of all, let's find our restrictions. Now I'm not going to do all this work up here, but you should be able to do this without that. So in this particular case, y is not allowed to be a positive 1 because 1 minus 1 gives a 0. So it can't be 1. And here it can't be a negative 3 because negative 3 plus 3 gives a 0. And then of course we have 1 here, and then here it's negative 3. So we're set. All right, hold on. So if we come up with those answers, we got to kick them out or 1 out. It doesn't matter. All right, so what we're going to do is find our least common denominator. Our LCD, every single time, write down your first denominator. So it's y minus 1. Go to your next denominator. Do we have a y plus 3 listed? We do not, so we need to add another that on there. We need to list it. Do we have a y minus 1? Yeah, we already have one. Do we have a y plus 3? Yes, we already have one. So that is our least common denominator. Now, again, you can go over here and you can list them like this. Be careful because you have a subtraction sign. But I'm not going to deal with the subtraction sign yet. And I'm going to put that in parentheses because that can't be split up. It cannot be split up. Same thing here. The y and the 3 cannot be split up. So, all right, so we're going to take all these. We're going to multiply it by our least common denominator over 1. Okay. All right, so now we're going to start canceling. Those two cancel to give us ones. I'm really bad about not writing the ones because when you multiply by 1 it doesn't do anything, so I just kind of ignore it. 1 times y plus 3 gives us y plus 3. Right here, your y plus 3's cancel, your y minus 1's cancel, so you're left with y plus 1. And right here, your y plus 3's cancel, so you're left with y minus 1. Okay, so now be careful because of that subtraction sign. When I took this and multiplied it by our LCD, we got y plus 3. Now, minus anything that follows, those signs are going to change. We are subtracting this y plus 1. Okay, if that was a plus sign, I would have just written it and gone with it, but it wasn't. Anytime you have subtraction, you got to be careful. When you multiplied this times that, you ended up with y minus 1. Now, what happens here is you got to distribute that negative sign. So you get negative y minus 3 equals y minus 1. Over here, those two cancel to give us 0. And this cancels with this to give us 0. Okay, so on this side, we end up with 0 equals y minus 1. Add 1 to both sides, and we get y is equal to 1. But the problem is that is one of our restrictions. So we have to kick it out and we say no solution. Sometimes though, you'll have more than one answer down here. So later on in the semester. So that is no solution. Okay, and that's it for homework 2.